Good afternoon, everyone. Today we are going to discuss about refraction of light. Very important topic for light reflection and refraction. So our topic is refraction of light. Okay. So we know that the light travels in a straight line path through a medium. Means if the medium is homogeneous medium means it have the same density throughout, right? But when a ray of light travels from one transparent medium to the another transparent medium, then the ray changes their direction at the boundary separating these two media. What I mean by this, suppose this is the surface and here is the ray, one coming out. This is the two different medium, rarer and denser. I will tell you rarer medium which have less density, denser medium which will have more density, right? Now when this is the incident ray and this is the normal, when the ray of light will move, so it can happen like this. Either it will move towards the normal or it may move away from the normal, right? When it happens, when it moves from denser to rarer. So this phenomena is known as refraction of light, right? This is known as refraction of light. Rarer and denser is clear to all that what is rarer, what is denser. Less density, rarer medium. High density, denser medium. You can take an example of water and honey. Water is rarer than honey, or honey is denser than water. So density means यहाँ पे heaviness you can see, right? So what happens when the ray of light move from, you say, rarer to denser. Rarer to denser. Then you can see here it is bending towards the normal, right? If I draw a straight line, the straight path iska ye banta tha, but it is bending towards the normal. Same way, its straight path was like this, but it is bending away from the normal. Why it's happening? Because rarer is lighter. Like you can take an example of air to glass, right? Air to glass. This is the meaning of denser and rarer. So lighter to heavier object. Then the speed of light slows down. Light decreases. Due to this, it's bending towards the normal. Right? On the other hand, if simple example you can take in water, and in water full of swimming pool के अंदर अगर water हो, swimming pool के अंदर honey हो, in which we can easily swim in water because rarer है उसमें speed ज़्यादा रहेगी, denser में speed slow हो जाती है. This is the main reason behind this. Same way, when the ray of light will enter from denser to rarer medium, we know that denser to rarer medium में क्या होगा? Speed of light will increase. Speed of light increases, right? Due to which the ray of light bending away from the normal. This is the what happening from rarer to denser or denser to rarer. Okay. Now the next is that what is the reason of this cause of refraction of light? We know that why it's happening, why the ray of light is bending towards the normal, bending away from the normal, why it's not moving straight? Because the speed of light in vacuum, we know that speed of light in vacuum, everybody knows speed of light in vacuum is 3 into 10 raised to power 8 meter per second, right? And speed of light in other transparent medium is always less than this value, 3 into 10 raised to power 8. So refraction of light occurs because the light travels with different speeds in different mediums, right? Actually, the speed of light hoti hai, that is the property. Speed of light is a property of medium, right? And this property is known as refractive index. Very important. Refractive index of medium. Always remember which property of the medium, right? Represented by the speed of light in it. That is refractive index. What I mean by this refractive index, very important term for refraction chapter. So refractive index is actually can be defined as speed of light in air, speed of light in air divided by speed of light in medium, right? इसको हम n से denote करते हैं. It can be written as n is equal to c by v. This is the way that how we can write. So higher the refractive index, more denser will be the object, right? जिसका refractive index ज़्यादा होगा वो ज़्यादा denser होगा as compared to the lower value of refractive index. For example, if I say for diamond, the refractive index is 2.42, right? Diamond it's 2.42 and water it's 1.33. So in which medium the light will travel fastest? In water, because 2.42 means it is denser, and denser medium में light speed of light जो होते हैं that slows down. Ray of light will slows down. And what is the meaning of if I say refractive index of water is 1.33? What is the physical significance of this refractive index? It tells us that speed of light, put up the value here, 1.33 is equal to c by v. Suppose it is water, so v for water will be is equal to c by 1.33, or I can say c is equal to 1.33 into speed in water. So what is the physical significance of refractive index? Refractive index tells us that if refractive index of water is 1.33, it means that speed of light in air is 1.33 times the speed of light in water. This is the meaning of refractive index, right? So always remember this, very, very important. Okay, then we have the laws of refraction. As we were having the laws for reflection, so we are having laws of refraction. So what are these? The first law is same. Incident ray and refracted ray and normal all lie in same plane. That is same as reflection. All lie in same plane. Secondly, for any two media and for light of a given color, the ratio of sine of angle of incidence to sine of angle of refraction is always constant, right? This is known as Snell's law. Snell's law भी बोलते हैं इसको, right? And this constant is also called refractive index of the second medium with respect to, if I am writing like this, so refractive index of medium 2 with respect to medium 1. This is the meaning of laws of refraction of light, right? Okay, then along with this we are also having relative refractive index. This is very important because the numerical can come from this portion, relative refractive index. Okay, so let's do that. So when a ray of light, suppose it's moving from one medium to two, right? Suppose I'm drawing the diagram. Ray of light is moving from one medium to two. Bending of light is there. This is medium one. This is medium two. Then the refractive index of medium 2 with respect to medium 1 will be the relative refractive index. उसको हम कैसे लिखेंगे? 1 and 2. Again I am writing refractive index of medium 2 with respect to medium 1. Right? Now let V1 is the velocity in this medium and V2 is the velocity in that medium. So refractive index of medium 2 with respect to 1 can be written as N2 by N1. Now N2, we know that N is equal to C by V हमने किया है. If I am writing N2, so N2 means C will remain same, C by V2. N1, C by V1. So it will become V1 by V2. Right? Similarly, if I want to write refractive index of medium 1 with respect to medium 2. So how I will write? I will write like this: 2 and 1, that will be equal to V2 by V1. Right? That it is first equation, this is second equation. Now multiply 1 and 2. Multiply first and second. So what we will get? 1 and 2 multiply with 2 and 1, that will be equal to V1 by V2 into V2 over V1. Right? So it will get cancelled. So what I will get? Refractive index of medium 2 with respect to medium 1 will be equal to this. Reciprocal of the other medium. Right? This is the meaning of relative refractive index. Very simple. We can understand this by saying that when we are relating the two refractive index of two mediums, two different mediums, right? Okay. Now one very important thing I would like to share about the bending of light. We know that bending of light is there. I told you, when a ray of light passes from one medium to another. Right? I told you them denser to rarer it moves and this happens, rarer to denser this happens. Now I will explain you how it happens. This is the boundary. This is the ray of light striking the mirror. This is our normal. This is our refractive ray. Right? This medium is rarer. This is denser. When a ray of light is entering from rarer to denser medium, then let the refractive index N1 to denser medium of refractive index 2. Refractive index is N1, iska hai N2. Now from this we know that N2 will be greater than N1. So if I use Snell's law, from Snell's law, very important, but try to understand this. Sin I by sin R will be equal to, we know that 1 and 2, or I can say N2 by N1, right? N2 by N1, that is greater than 1. So it implies sin I is greater than sin R, or angle of incidence is greater than angle of refraction. So what does it mean? ये जो angle है, that is angle of incidence, this is greater and this is smaller. So that means it's coming closer, right? अगर इस तरफ जाएगी तो angle increase होगा, and if it is coming towards the normal, then the angle will decrease, right? Second part, same. If I talk about another formation like this, now denser to rarer. denser to rarer. Again, N1, N2. Now, N2 is less than N1. Same way, sine I over sine R will be is equal to the refractive index like this. So N2 by N1. Now it is less than 1. So it will become sine of angle of incidence is less than sine of angle of refraction. Or I can say angle of incidence is less than angle of refraction. So this angle is less than this angle. It's very clear if the angle is increasing or angle of refraction is greater than angle of incidence, that means the angle is increasing, the ray of light is moving away from the normal, right? So this is how the denser and rarer medium acts. With the help of Snell's law, you can prove that why or what will happen, show with the help of diagram or prove that the ray of light moves away from the normal when moving from denser to rarer or rarer to denser when it's moved towards the normal. So this way we can, okay. Then we are having, there are some cases when there is no refraction. So conditions for no refraction. What are these conditions for no refraction? Right? When a ray of light moving perpendicular or incident normally on the surface, right? So here the ray of light, then it will not show any refraction, it will pass straight. So what will happen? Sine of angle of incidence to sine of angle of refraction, right, is equal to, if this is, let this is air and this is glass, right? So it will be refractive index of medium 2 with respect to medium 1, that is N2 by N1 I can write. So what I will get, sine of angle of refraction will be equal to N1 by N2 into sine of angle of incidence. This I can write. So this is the relation for the refraction with angle, right? Sine of angle of refraction. Now you can see I is equal to 0. I is equal to 0 because there is no angle of incidence. So incident ray hai wo, that is on the normal, and the angle always formed with the normal. So what will happen? I is 0. It implies sine R will be 0 or angle R will be 0 because sine theta कब 0 होता है? 0 degree. Sine R. So angle of refraction will be 0. तो इसी वजह से straight निकल जाए. Right? And secondly, when the two mediums have equal refractive index, when N1 is equal to N2, put up the value sine of angle of incidence upon sine of refraction, refractive index again N2 by N1, right? Now N2 is equal to N1, so it implies sine I is equal to sine R. Angle of incidence and angle of refraction both are equal. Means ये देखिए, if this angle is I, तो ये angle equal कब होगा? ऐसे जो बिल्कुल straight जाएगी, तभी ये vertically angle opposite equal होंगे ना? So that means these angle will be equal. So it will go straight. So these are the two conditions when there is no refraction takes place. Right? Very simple. Okay. Now you might have heard about the glass slab. Two refractions. So a glass slab. क्या होता है ग्लास स्लैब? ग्लास एक बिल्कुल इस तरीके की स्लैब है हमारे पास. So when the ray of light coming here, right, we know that this is normal, this is angle of incidence, and this is normal. Let this point is A. Now, as this is air and this is glass, so what will happen? The ray of light will bend towards the normal. Yes. So this is the angle of refraction. Refract ho gaya. Now what will happen from here? Again, it will strike this boundary and it will move like, because now it will move away from the normal, right? It will move away from the normal. If I see these lines, right? So actual ray यहाँ थी तो कितनी डिस्प्लेस होगी? इसको हम बोलते हैं लेटरल डिस्प्लेसमेंट. Lateral displacement, right? And this angle we called angle of emergence. Angle of emergence, that is E, right? This was the direction of original ray and this is angle of emergence. This is an activity can be performed in the labs. Now I would like to discuss some numericals. Like one numerical, it is given. What is the real depth? What is the real depth of swimming pool? I will share a practice question on the basis of this. When its bottom appear to be raised, by 6 meters, right? So what we can do? We know that refractive index जो होता है उसको हम एक और फॉर्मूला भी लिख सकते हैं, रियल डेप्थ अपॉन अपर एंड डेप्थ. Real depth upon upper and depth. So we have to find out the real depth. So real depth will be is equal to refractive index into upper end depth. Refractive index of water is 4/3. Upper end depth is 6. 3 to just 6. It will be 8 meters. This will be the real depth of the swimming pool. So this way we can solve the numericals. I will share some of the numericals for the practice.